Hi everyone. So today we'll be making the video showing the next step after using the amplified DNA polymerase for the whole genome amplification. So after using the amplified DNA polymerase to amplify our cDNA or DNA, the next step is to use endonuclease to perform an endonuclease treatment. So in this case, we'll be using the endonuclease T7 to cut our DNA, our large fragments of our large DNA into little fragments. So to do that, we'll be using the endonuclease T7. So, but the first thing we need to do when we want to perform the endonuclease treatment is to perform a purification step. So the last video before treating with liquefied DNA polymerase, I showed how to perform the purification. So to perform the purification, we'll be using the magnetic beads like we always do, and ethanol. So we'll wash with ethanol twice, and we elute our nucleic acid. So for the sake of this video, we won't be showing the purification step again because we've already done that in the previous video. So I'll go into endonuclease treatment. So here what I have is a protocol of how to carry out this next step. So what we need 1.5 microgram of amplified DNA. So but we are dealing in nanograms, not in microgram, meaning we have to convert first. So we all know that 1,000 nanogram gives you 1 microgram. So if we're gonna need 1.5 microgram of DNA in our sample for the endonuclease treatment, it means we have to divide our the concentration of each DNA. We have to divide 1.5 microgram with the concentration of each DNA. So, and we have to convert as well. So 1.5 microgram to nanogram is 1,500 nanogram. So we divide 1,500 nanogram with any with concentration of each of our DNA to get the volume we need to perform the next step. So this is what I mean. But we need 1.5 microgram of amplified DNA. So here you can see I did the calculations for 4 samples already, 4 of my samples already. So you can see the concentration of my sample 1 is, after purification of course, is 367 nanogram. So you divide 1,500 nanogram by the concentration of your DNA to get the volume you need for this next step. So here I have 12 samples from yesterday after the amplification using the amplified DNA polymerase and purification. I have 12 samples. I'll be in a new tube. I'll make the required volumes for this endonuclease treatment. But first, I will clean my working space again with 70% ethanol. So next thing I'm going to do is to clean my working equipment or apparatus. So in a new 200 microliter PCR tube, I would prepare these volumes for different samples. Always remember to label your tubes. If you remember, in this case, I'm working with 2 controls. And if you've followed me from all the videos I've posted, you would know that during the filtration step, after the filtration step, when treating with rapid out DNA, I had a control, and during the treatment with equified DNA polymerase, I also had a kit control. This is to monitor the progress of my of the whole reaction and to able to trace back where there might be a contaminant, in any case there is a contaminant in the sequencing run or after the sequencing run. So right now I'm going to prepare the required volumes for each sample. So using my P20 for the first sample, I need 4 microliter of my sample. For the second one, I'm gonna need 7 microliters. So for the third one, I'm gonna need 3.5. For the fourth one, I'm going to need 10 microliters. So after taking the required volumes from each sample, the next thing I'm going to do is to use nucleus-free water to add up or make up for the volume, because I need a total volume of 24 microliter for each sample according to the protocol. So I'm going to take, for the first sample that I added 4 microliter, I'm going to take 20 microliter of nucleus-free water. So I'm going to mix by pipetting up and down 2 to 3 times. So for the second one that I added 7, I'm going to need I'm going to need 17 microliter of nucleus-free water. So for the third one, I'm going to need 20.5. So I'll use my P100. I'm going to need 20.5 of nucleus-free water. So for the fourth one, I'm going to need 40 microliter of nucleus-free water. So remember to always mix by pipetting 2 to 3 times. And for my controlled sample, my last sample, I'm going to need 15 microliter of nucleus-free water. So when I'm done, I'm going to add 3 microliter of endonuclease and 3 microliter of the endonuclease buffer to each sample. So I'm going to first start by adding the buffer, 3 microliter of endonuclease buffer to each sample. So I'll be adding 3 microliters of my reaction buffer to each sample. Always mix by pipetting. You can also mix by flicking, but in this case, I prefer to mix by pipetting 2 to 3 times. And to my control sample, next thing I'm going to do is to add my endonuclease polymerase to each 3 microliter to each sample. So I'm going to add 3 microliter of the endonuclease T7 enzyme to each sample. To my control sample, I'm going to add 3 microliter as well. So next thing I'm going to do is to set up the PCR reaction. So I'm going to have it in the thermocycler for an hour at 37 degrees Celsius for an hour. Always make sure your tubes are tightly sealed. So after the reaction is done, the next thing to do is to perform another purification step before you go on with the DNA library preparation for the Oxford nanopore sequencing. So when this is done, you perform the purification step like I did in the previous video before you go on with the Oxford nanopore sequencing. So thank you.